Hi, this is Charles C. McGowan with the SolREI Company. This is part of a series of informal videos that we're going to be doing on various topics. This particular one is Elegant Reasonism, a brief introduction and overview. It is a set of charts that are online. You can go and download the PDF file from the user library on solrei.co, SOLREI.co on the web. You will need to register in order to download it, see it, download it, whatever. And the best way to look at these charts is to log on to the website and then bring the PDF file up, and that way all of the hyperlinks that are in the file will resolve to their respective pages back in the website. And I am shooting this video today from a hangar, and I apologize if you hear some airplanes go by. With that, let's get into the presentation. And this presentation concerns really what the patent is. It's not about the systems review that we undertook to get here. It's not a discussion about the history. It's not a comparative analysis. It's not a justification for elegant reasonism versus some other way to think. It is simply a description of what the patent is, because we're trying to help people to understand that and go through that, and then we will back up and tell those other stories in other videos. Patent pending 16405-134, Elegant Reasonism, is the framework and epistemology required to perceive and engage the unified universe. Our patent includes the first fully compliant model closing to unification. We call that the Emergence model. And the one thing that we would ask you to take away from this presentation is to be aware, is the situational awareness, is that unification is a tapestry a great deal larger than any single discipline of science. Its criteria must be holistically describe the unified universe consistent with nature as a philosophical predicate priority consideration. That means that we have to be able to pretty much describe everything, and as we go forward in the coming months and years, you'll see that elegant reasonism does do that. We've been chasing this for about 16 years at this point, and we will tell you that every test we've undertaken to disprove it only strengthens the model, and it just dovetails with everything that we test it with. So what does that mean in terms of an executive overview? Well, elegant reasonism is a process utility that quantifies and codifies systemic abstractions, philosophically poised as a fundamental foundation construct. It encapsulates them within interpretive models, and then it juxtaposes those with a plurality of such models against an investigation's paradigms of interest or of nature in context of and in compliance with the unified universe for investigative purposes. The information is then subjected to scrutiny and analysis in order to develop insights that would then be documented in a treatise for comparison with the real unified universe, which is always held litmus. The important takeaway here is that the models, and you'll see in a minute the tools that we use, we never ever say that we are describing actual reality. We are creating descriptions that reflect what we think reality is, but we never say that we are actually developing a description of actual reality. And we do that distinction, may be a very fine distinction, but we do that for a very good reason, and you'll see that in a minute when we talk about epistemology and epistemology errors that can be made if you don't do that. So why are we doing all this? What is this all about? And the answer to that is because predominant thinking does not, nor can it, accomplish unification. When you look at the predominant way of thinking today, it uses constructs like space-time and mass, and it has rules and regulations and things like that, and the physicists will call them laws and etc. The space-time, when we look at that and we back up and we look at space-time, we realize that there's a space-time mass interface, and that nothing real can transit that interface. Because predominant thinking does not integrate the implications of what we call Langer epistemology errors. What's that? What's a Langer epistemology error? Well, anytime you mistake an abstraction for actual reality, it is a fatal epistemological flaw in thinking. Systems engineering principles and practices must be integral, and they are, to what we filed as and are now patent pending on. Because the traditional epistemologies like empiricism or rationalism or constructivism, because those traditional epistemologies do not adequately take into account that human physiology is holistically intrinsic to what must be philosophically defined as a predicate priority. Human physiology is the common denominator for all of the traditional epistemologies, and it is also their strategic Achilles heel. And you'll see that again when we get into talking about Langer epistemology errors and who Suzanne Langer was, because she's the first one to talk about that kind of an error. We named the error after her. And because accomplishing unification requires this larger tapestry that includes philosophy and including all of its subsidiary disciplines, including science, and its specialized methodologies and laboratories, etc., we must require a contemplation of unification as a predicate priority consideration in everything that we do. And so that's a little bit about why we went down this road. When you look at layered abstractions, we find that any abstraction has a tendency to insulate and isolate lower ordered details from higher ordered ideas. And the more of those that we layer between us and reality, we get into a situation where that geneticists would call replicate of fading. And it shifts how we perceive what it is we're actually dealing with. So for example, I may have a bottle of water, and I could call that a bottle of water, and everybody watching this video would know what that meant. On the other hand, I'm probably not going to say things like, well, this is a clear polymer containing H2O, and it happens to be at a temperature of, 39 degrees Fahrenheit, or some degrees Celsius, or some other degrees Kelvin. And the point is that I could come up with any number of labels that represent this bottle of water. I could call it a refreshment. I could call it just water. And the point there is that that's a logical representation of what the actual object in reality is. And when we start going down that path, we realize that what Einstein actually created was a logical description. And so we'll get into that in a minute. But the point here are the layers of abstractions between us and reality. And the example that's on the chart that here is just an example. It's not meant to be anything more than that. There could be 100 layers, there could be 20 layers, there could be, this particular example has 10 layers. I think the international community needs to come together and kind of decide what everybody wants to use as an example, and really kind of flesh that out and do that. But this is just a benchmark kind of straw target for everybody to throw darts at and to get the point across. Core constructs for any given encapsulated model would be at the bottom of these layers. So they have to represent the fundamental constructs that are in the interpretive model. And what we find is that those core constructs are highly systemic, and they flow up through every order of abstraction layer, from the simplest to the most complex, and they must be in every single one. So what are the implications of why? Well, failure to recognize Langer epistemology errors leads directly to logic traps manifesting the erroneous belief that we are working directly with nature rather than the abstractions of it. And that is a fatal flaw in epistemology. And epistemology is a philosophy of knowledge. It is a philosophy of how we gain knowledge. It's how we describe it, how we justify it, how we rationalize it, etc. And the point here is that layered, highly systemic abstractions leads to replicate of fading issues between higher ordered ideas and lower ordered details, as well as a complete loss of situational awareness regarding these issues. That is to say, ideas are insulated and isolated from underlying detail, and therefore the solution to unification must reconcile these issues. The framework that you develop and deploy must be situationally aware of these kinds of errors and must be equipped to handle it. And in this presentation, we'll show you how we did that. So what is the elegant reasonism? Well, we call it a framework, and in an epistemology, the framework is the process and methods that we employ. The emergence model is the first encapsulated interpretive model to close to unification as a philosophical predicate priority. And the epistemology is the philosophy of knowledge which seeks truth as a function of the unified universe. So let's discuss what these concepts mean and their implications to what it is we think we already know. So when we talk about the implications to what it is we think we already know, what does that mean relative to elegant reasonism, and how do we do that? How do we get there with that objective? And part of the answer is that elegant reasonism has a requirement that at least one of the encapsulated interpretive models that's used in any given investigation meet what we call the realm of C's. It's words like cogent and coherent, etc. One of those words is closure, and what we mean by closure is that it closed to unification as a philosophical predicate priority consideration, and that's something that's not heretofore been done. And we're going to talk about the systems review that we did over the last 16 years or so, to how we actually were able to accomplish developing that model. When you see the cogent description for M5, you have to know that that was the end result. We didn't just sit down and write that. We had to reverse engineer that from all the stuff that it was that we thought we already knew and come up with that. And it was a very hard won paragraph, but now that we have that paragraph and we can look back on it in hindsight, it's a very powerful paragraph. So what does that paragraph say? Well, the M5 cogent description says, and I'm reading this because I don't want to, I may paraphrase it from time to time here, but the presentation has the exact language in it, as does the website. Okay. The The emergence model's logical view, M5, logically draws its basis from most basic particles, or MBPs. MBPs are the quintessential integer, and it is through their intrinsic nature all other concepts are derived. It is the MBP in M5 which manifests the three dimensions associated with all real objects, not space. M5 is centrally characterized by the two processes so derived: the fundamental entanglement function, which is limited by the other, severance. The fundamental entanglement function is the build process, entangles MBPs into all configurations of architectural mass, generally envisioned to follow knot theory, including dark matter, within any given event frame. Severance, as an independent process, is the failure mode of any given configuration of MBPs and represents the limits of architectural mass to remain intact specifically due to the intrinsic nature of constituent MBPs. Space in M5 is dimensionless nothing. Force, all force, is the work instantiated through the intrinsic action of configurations of MBPs forming architectural mass. Architecture of relative and respective constructs so configured determines physical properties which manifest. Time is an action displacement index of the relative and respective architectural masses in the frame. Energy is the ability of relative and relevant architectural mass to do that work. So that's the cogent description, and when we go back through the abstraction layers from the smallest objects to the highest objects, and we start talking about force, we inevitably come to a discussion about properties. And if you've studied science at any given level, you've heard the phrase structure equals properties, and the converse of that is that properties infer intrinsic structure. And the observation that we make is that we're replacing the word structure with architecture, and it is architecture of mass that is the most important takeaway here. So, what are the tools of elegant reasonism? Well, the two predominant sets of tools. One is the ISO 9001 unification tool. It is a software database tool that you can populate in with your definitions for each of the models that you are employing in your investigation. And we do make you quantify those concepts, every single one of them, and then you can apply those to, and the paradigms that you investigate must use those definitions. And once a given encapsulated model has been quantified and codified, it may be iterated, but it may not be changed. And so you would then reference the model M1 dot and some 4-digit number or some other number that refers to the specific instance of definitions there. That way you can have a discussion about tweaks within a model, and the tweaks refer to the different iterations of an instance, but the basic core constructs are still there. The other major tool that's a part of the framework is something we call translation matrices. It is a derivative of a translation matrix that's on an IP server on the internet. There's basically a two-dimensional table that's on these IP servers that when you connect to the internet at your ISP and you put in a human readable URL address, that human readable URL has to be converted to either an IP4 or an IPv6 address, a machine readable address out on the internet somewhere. And we borrowed that concept and applied it here. And on this next chart, the columns of translation matrices represent each of the 7 recognized interpretive models, M1 through M7, where M1 is the modern variant mass idea or constructs, and many if not most of the modern physicists and scientists and teachers and pretty much everybody thinks that mass is variant. So if you said E equals mc squared, they'd think that the m in that can change its value depending on other things. As it turns out, and many people will say, well, that's what Einstein thought. That's not actually true. Einstein did not believe that mass was variant, and that is the next model is M2, is Einstein's invariant mass model. M3 is the physical view of M1 or M2. There's a story behind that we'll leave for another video. M4 is, it turns out that in M5, when we take different instances or different scenarios in it, that we can use the value 1, and we can force M5 to emulate either M1 or M2. And so M4 becomes that instance for investigative purposes, so that we can, and it helps us to ferret out what it is we think we know with what insights the actual unified universe have for us. So it helps us to understand and see the distinctions and differences between what we thought we knew and the actual unified universe. And then M5 is the logical view of the emergence model, and I just read you the cogent description for that, or you can read it yourself. It's in the set of charts that are online. You do have to be a registered user to see them. And then M6 is the physical view of the emergence model. We don't look at that for reasons that we'll cover in another video. Pretty much that's something that's going to be pursued at a later date. And then M7 is reserved. It's not used for anything. And I guess I'll just tell you real quickly that when many years ago now, and this goes all the way back to like 2005 or 6 maybe, we made the mistake of thinking that Einstein actually believed that mass was variant. We were ignorant at the time and weren't really thinking about that. And it was only later when we were going over Dr. Lev Oken's work, and he showed us that no, that's not what Einstein thought. And there's a systems engineering requirement that every physical system has 2 views, has a logical view and a physical view, which would have meant that M1 would have been the logical view of the variant mass model. M2 would have been the physical view of that same variant mass model. Then M3 would have been the logical view of the invariant mass model, and M4 would have been the physical view of that. M5 would have been the emulated mode of M6, same thing for the emergence model, and then M7 would then be the physical view of the emergence model. But by the time we realized that error, we had already had significant. We have about 3,500 pages of insights documented, over 400 equations, and 300 and something gigabytes, almost 400 gigabytes of data that we've been looking through. And so we had significant momentum down this path, and we weren't going to go back through everything that we had already done to relabel all this stuff. And so we simply note that the error was made. We leave to posterity whether everybody else wants to get in here and say, oh no, let's reorder these because McGowan, whatever. And so that's why M7 is reserved. in case everybody wants to go back and renumber everything. But it's just easier. It was just easier for us to just say M5 is the deal, and we call it M5, and you'll probably hear me say it call it M5 until I die. It's just it's part of how I think and part of what I do now. So anyway, those are the 7 interpretive models. Excuse me. The rows are the paradigms of interest. So each row must explicitly declare, or that is to say, how it's made manifest by the rules of each individual interpretive model. So if space, for example, you'd have to declare exactly and to the rigorous, disciplined definitions required by geometry how that is made manifest across in each of these cells for if in one there was the paradigm of space. And I use that example because one of the things that M1, M2, and M3 do not do is to declare where the geometric basis of space is. It is rationalized away by saying it's irrelevant. Well, it's not irrelevant. And that becomes an issue when we put our critical thinking hat on and we realize that the space-time mass interface, that nothing real can transit that interface. And that's the reason. That reason is what precludes us from being able to use a single geometric basis point for any given real object in any reference frame, whether it's an inertial frame or not. So systemic paradigms are included to assure the integrity of any given investigation. That is to say, if you have something that's at the bottom of one of those layers, lower level layers, it must be demonstrated how it is made manifest through all the higher ordered abstraction layers. And then on the chart here, each intersecting cell must manifest 100% of the relative and respective paradigms. To the extent that it involves other paradigms, they must be referenced for a complete pattern recognition. And pattern recognition is, within any given encapsulated interpretive model, is important, especially when you start going across like the number of equations that we did in our systems review. We went through over 400 of them. And if you look at really complicated formulas like the Schrodinger equation or some of the other stuff that maybe includes black holes or those things, those equations get very involved and refer to many different other aspects of astrophysics and physics and constants and those kinds of things. And so you just have to make sure that everything that's involved in all of the patterns relative and respective of a given investigation are included for systemic referencing purposes. So how do these tools relate to each other? The definitions for all the different encapsulated interpretive model go into the ISO 9001 unification tool. They're just quantified and codified there. And those definitions must then go over into the top 2D, we call that a 2D articulation layer for the translation table. And that's how those things move over there. But they have to be documented in the ISO 9001 unification tool, and everybody on a given investigation team must use the same tool and the same instance of the same tool. That's important because when you get into a meeting and you have a discussion about something, it has to be clear to everybody involved specifically which definition is being used for any given discussion. And so this tool and the translation matrices, it does not let you get away with saying things like, oh, well, we don't need a geometric basis point. It forces you to make sure you do in fact have one, or it makes you recognize that the model that you're working with is a logical model, not a physical model. So what are the layers of what is the analytic framework of the translation matrices? Well, that top layer is the 2D articulation frame. And so that first cell up there, that's everything that you would see on that preceding column. So all the paradigms of interest are represented there, and that's what's in that top layer. Context and source, that's historical context. If you need to go back and articulate where where constructs and concepts came from historically, and you need to reference documentation. For example, if you needed to put links back into our user library that's online that registered users can use, and use for this purpose, by the way, then all of that material is there and there for you to use. The model integrity analysis is simply a check, a metrics, if you will, to make sure that the patterns are all complete and that the articulation of each of the paradigms of interest are in place and meet their requirements to the degree and requirements as established by ISO 9001. And ISO 9001 is a quality process, a quality management system that imposes standards on how things are done and how things are documented. And that's why we call that unification tool the ISO 9001 unification tool. That's why it has the name it does. The M2M paradigms, this is an analytical layer that we found fairly useful. It compares M5 descriptions, for example, if you needed to compare the manifestation of time, for example, between M1 and M5, you would find that over in M1, time is a dimension of space-time, and it flows in primarily one direction, but it mathematically is defined as having two dimensions, forward and backward, and at least on paper, it looks like you might be able to do that. The problem is, in physical reality, that's not how everything works. We have yet to see any examples of being able to go backwards in time. And when we move over to when we mode shift that concept, that paradigm that we label time, into M5, we find, for example, that time is an action displacement index, and that's why it only flows in one direction, because action always flows in a positive direction. So it can only be indexed forward. And so even if you back up, you're still indexing it forward. So anyway, that's an example of mode shifting a concept across these, and that's where you would check the analytical rigor and make sure that that's complete model to model is on this layer here. Then there are paradigm statistics, different metrics that you can use to make sure that the metrics are, or that the paradigms are being articulated within the realm of C's and meet all those requirements, and you can have metrics for all those things, and that those things close and meet the statistical alignment that they need to is the purpose of that layer. This next layer we call logic calculus. It simply is where you say, if this is true and that's true, then this other thing may also be true. And you can do pattern analysis, and you can do comparative analysis with patterns, and you do that here. The next layer down is a reality validation, and as we've said, that no model is allowed under elegant reasonism rules to say we are describing actual reality. We don't let you do that. We can say that you can build a description that reflects actual reality, and we think it's pretty close, and that the alignment is has a great deal of affinity with it, but that's as close as we can get. We can't step over that one last line, because if we do, we may commit Langer epistemology errors, and that's one of the objectives that we have for elegant reasonism is that it minimizes and eliminates those kinds of errors. And so that's why we have that, that's why that line exists. Bayesian analytics is included as a layer because what we have found is that denial is a powerful thing, and we needed a way to to integrate belief systems into the analytic rigor of the framework and the epistemology, and we do that with Bayesian analytics. Bayesian statistics includes before, during, and after belief systems in a statistical manner. And so you can say this is true in M1, and we have this set of circumstances. And I apologize, there's an airplane coming by. I'm going to keep talking, and I'll see if we need to edit this part out. Sorry about that. So anyway, the Bayesian analytics piece is in there for that purpose, and it helps us to build those roadmaps, education roadmaps, in particular, after the fact, and once the insights that are in line and are documented in our treatise, how can we then take that and help other people to understand how to move from the old paradigm to the new paradigm. It's like, how do you move from the flat earth society to living on a sphere in space? And why don't we all fly off, etc. And so, and then there are the heuristics. It's the practical integration of various concepts and insights. That's what we do there. The metacognitive, I can't talk today. The metacognitive analysis or analytics just takes large groups of wow, so sorry about that. An airplane left from the hangar next door and I had to stop. So anyway, we're back. The metacognitive analytics layer is simply a set of metrics that help us to think through how we're thinking about something, and all of that. And so there's a whole description of that online and in the analytical layer detail on the website. And then Six Sigma is a quality metric that's used in industry a lot to reduce the number of errors, whether they be Langer epistemology errors or quality errors or other things. And so when we go back through the entire analytic stack relative to that first 2D articulation frame, we start collecting errors that manifest in Six Sigma values, or error ratios per million, or however you want to count them in the relative to Six Sigma. And so that's where you get into issues like not being able to deploy a geometric basis point matter. And so when we back up and look at that first encapsulated interpretive models chart, and we start asking why we need to encapsulate these things in the first place, we start running into some of those problems. No geometric basis point, for example. It forces us to think through whether how we're looking at something is logical or is actually physical. And if we make the mistake of believing that some abstraction that we may be considering is the physical view, and it is not, that constitutes an Langer epistemology error. And we'll get into that in a minute. So those are the analytical framework layerings. At a minimum, you can have fewer than these, you can have more than these, and some of these layers may have many layers within them. So don't think that there's only like 9 or 10 or whatever they are here. This is just an example set of layers to help you think through being able to enable mode shifting. And mode shifting is being able to take any given paradigm of interest and demonstrate and illustrate and illuminate how it is made manifest by the different encapsulated interpretive models. So, what is the framework? Elegant reasonism can be thought of as a framework needing to be populated by a given investigation, employing rigor, discipline, and techniques employed by enterprise worldwide. There's 3 basic phases or parts, however you want to think about it, that move from left to right, and I'll show you the generalized process flow chart in just a minute. But they are recognize, illuminate, and analyze, and then there's a development set of activities that lead you to the final treatise in the context of the unified universe. And again, there's a requirement that at least one of your models fully close to unification. Doesn't have to be M5 or M6. You can have another model if you want. If you can go do the systems review that we did and can come up with one, go for it. Doesn't have to be ours, but ours closes. Intend ours closes. We've done a lot of rigor and analytical rigor on it, and you guys are welcome to go test it yourself and come to the same conclusions. We're pretty confident that you will when you do. And so the recognize phase is you have to comprehend what the problem or challenge is before you can solve it. You can't fix something if you don't know it's broke. And so that's how we get into issues like the multiverse and other kind of strange theoretical constructs that we have not been able to analyze to a conclusion, that we know what that idea is about. We can do that now with elegant reasonism, and in that particular case of the concept that we call multiverse, I can tell you that that's a logical construct that evaporates in the literature of elegant. I'm sure there's going to be a lot of people that are not going to like that answer, but that's what happens. When we move into the illuminate phase, is when we're actually populating the translation layer and the translation matrices that we're going to use down through all of its articulation and analytic layers. And as you complete those cells and demonstrate how any given set of paradigms is made manifest by the different encapsulated interpretive models, you illuminate insights that you most probably did not see and could not see coming, and it's jaw-dropping when that happens. It's an awesome experience to go through. You will find that it's tacit and palpable. You will be able to, you will know that you went through that experience when you go through it. And it will make you giddy with excitement. It did us anyway. Then the analyze phase is when, after the translation matrices are populated, is when you can go back and you step back away from the translation matrices tool and the unification tool, and you just double check everything, and you start looking at the holistic insights that you're gaining from having done that exercise. And that too is incredible. And you will probably start having more insights than you did when you were populating the tool in the first place. It's just a powerful thing that I cannot describe with words. It's almost an ineffable kind of experience that you have to experience in order to know what it feels like. Once you do that, though, then you can develop a treatise, and this is actually how we came up with the emergence model. The emergence model is a product of this framework and epistemology. So the emergence model is a product of these three parts or phases, and went through the development phase, and is a product of the treatise that we developed that accomplished unification. And we turned around and made it part of the asset that we filed on the patent, because we wanted to offer it up as fodder for people to look at and consider. But it is the elegant reasonism is the framework and the epistemology. The emergence model is the product of having gone through that framework consistent with that epistemology. And that's how to think about those three things different from one another. The next chart is the elegant reasonism general process flow, and it's a really busy chart. I'm not going to read it all to you. You can read it yourself. But it just know that it's moving left to right. You're going through each of the phases with the ultimate goal of having a treatise that is in line with the unified universe. So looking then at the general process flow, it should be obvious that there are decision checkpoints that you have to go through, and that's how we get to the process decision checks flow chart. So in the upper left corner is unified thinking, and it's basically a yes or no question. Most people will have to answer no to that, which means that you need to go through an abstraction inventory, which means you need to go through that recognition part of the process. And then flowing down from that, you need to decide whether you're working with abstractions or you think you're working with reality. Many people will say that I'm working with reality, in which case they're going to have to learn what constitutes a Langer epistemology error. And then they go back up and say, are you really committing Langer epistemology errors, yes or no? And if you have to say yes to that, then you're going to go through that process again, and you're going to get hung up in that loop. And that's really where civilization has been for the last quite a few decades, if not a century, is hung up on that left-hand side of the loop. We thought we were working with reality when in fact we were working with abstractions of it. So at any rate, once you comprehend what constitutes a Langer epistemology error, and you're confident that you're not committing those, then you can go to the next step. And that flows over to the illumination stage or phase of the process. You go down and you say, well, can I mode shift this from M1 thinking to M5 thinking effectively? And that's when you get into a discussion about metrics and the ISO 9001 processes and the various quality checks for effectiveness. And most people, when you first get into an investigation, you're going to say, no, I'm not doing that effectively. And then you have to go down through all of what constitutes the translation matrices and go through the analytic stack and the 2D articulation layer and all of that. And you hung up in this loop for a while until you can effectively mode shift, or you think you've got the translation matrices accurately populated, and then you go up and you reassess with metrics whether or not you're mode shifting effectively. And you can always, come out the bottom of this and go all the way back over to unified thinking and go through that loop again just to double check everything. And then you come back in and say, are you mode shifting effectively? And if you think you are, then that's when you can move on into the analytic phase. And then you go through the realm of C's. It's words like cogent and coherent and compliant. The most salient word there is close. Does it close to unification? But if it is fully compliant with all of those, the realm of C's, then you can go down and start developing your holistic insights. And then you have to ask what the objectives of your investigation were in the beginning. And, was that effective? Did you meet those metrics? And if you did not, then you go back through the analytic loop. If you were, then you can start working on your the unified treatise of your investigation that you were going through. And you can always loop back and improve any of the thinking and go all the way back through. But this is the holistic decision checkpoints of the general process flow. All of these in the PDF file are linked back into the website for these respective areas of discussion and contemplation. So you can mouse over any of these and then click it once you're registered and logged into the website, and pursue greater insights on any piece of this decision checkpoint. This next chart just describes what the emergence model is. For all intents and purposes, it is a mode-shifted version of the standard model of particle physics. It does have things on it that, like the graviton, that are not over there on the standard model, because if you remember, gravity is a phenomena. It is not a property. So those are Einstein's words, not mine. And so because in the emergence model, space is dimensionless nothing, it has no influence on anything. And so it is therefore almost never discussed. So all the physical properties that we make manifest in any given event frame must be a product of the interactions of the associated and relative architectures of mass that are some configuration of MBPs and the work that they perform. Severance. So when we talk about this in the standard model, we talk about photons and the speed of light. That becomes one of the rules in M1, and when we mode shift that concept, we find that the speed of light using the constant c, for example, that gets mode shifted, and c gets reassigned to severance as opposed to the speed of light, and it still produces the same number, still results in photons going the same speed, but the reason they're going that speed is different. It's not a dimension of space-time. It is a function of the system that produces the photon. We talk about that in another video later as well. But I'm just saying that there's multiple ways to think about different concepts, and when we mode shift those concepts, those paradigms from M1 to M2 to M5 or M6 or even in M4, then that's what we're doing when we're filling out those translation matrices and making sure that we can in fact do that, and that everything has integrity associated with it, and the numbers match and whatever, etc. So the emergence model essentially says that because everything is based on some configuration of MBPs, it means that everything real has mass as a function of the complex composite architectures that are configurations of most basic particles, or MBPs. It also means that everything real is a system or a system of systems, and therein lies one of the major reasons that systems engineering practices, principles, and even the profession of systems engineering are vital to the understanding the emergence model, how to deploy it through elegant reasonism, and assisting any given investigation go through the critical thinking necessary to develop the requirements of the investigation in order to develop a treatise. I can't emphasize that enough. It's just very, very important to deploy those skills in that process. So this and all models have two views, one logical, one physical, again, consistent with systems engineering principles and practices. And I'm going to pause here for a minute to talk about logical and physical views, because inevitably, and remember, Langer epistemology errors, which we're going to get to in a minute, is those errors occur because we mistake an abstraction with actual reality. And so the notion, and I get this a lot from physicists, because everybody wants to believe, because we've all been guilty of this. I know when I was studying aerospace engineering many years ago, we thought we were describing actual reality, when in fact we were describing abstractions of reality. But the belief, this is again why Bayesian statistics is important, and Bayesian Analytics. But when we believe that we are working directly with the physical descriptions of reality, the instinct, the emotion is to jump to that physical view. But you really don't want to do that. And the reason you don't want to do that is that there's almost always more than one physical way to accomplish the same logical result. When we have a logical view, logical views tend to be more precise because you're defining specific inputs and specific output values. The speed of light, for example. We develop that number from using interferometers, and we can scientifically measure those things. I know that a lot of the scientists will want to say, well, that's empirical evidence. Well, it's empirical evidence in terms of that epistemology in the context of the way we've always done science, but that same epistemology is also dependent on human physiology and the perceptions that we have. And since everybody on this planet is human, we all have the same perceptions. We have the same, we measure things the same way. We perceive things the same way because our senses are all the same. And in elegant reasonism, is a superset epistemology. So it integrates empiricism, but it would also integrate rationalism and constructivism. But it does that with statistical weighting associated with them. And then it integrates it back also with the Bayesian statistics. And as we start then applying Six Sigma to all of those various constructs, and we're mode shifting those things across interpretive model to interpretive model, those weights start to shift where things are. And so, for example, in the speed of light, we still show that we have the same speed, but the reason the photon is produced at that speed is different. And we wind up reassigning C to mean severance in M5, whereas it means speed of light in M1. So it's things like that that are shifted, and there's definitions that shift, and all of those things have to be taken into holistic consideration as you read a treatise. And it's important that you note in any given paragraph, if you're writing a paper or delivering a mathematical proof, for example, in a university paper or for homework, you want to make sure that the very first thing in a given paragraph is a set of parentheses and the model number. So if the text and language in that paragraph is primarily and predominantly M1 related, you want to say M1 in that predicate parentheses. You just want to put an M1 there. Or if it's M5 or some other model, you just want to put whatever model that is. So people know which model is responsible for the language that follows it. That's the point of that. And so that helps people understand whether you're talking about a logical view of a physical system and whether or not that physical system may be different than the logical view of it. And so that's how you tell people what it is you're talking about. So that's the emergence model. The epistemology, elegant reasonism as an epistemology seeks truth as a function of the unified universe. And while it necessarily integrates, as I just said, the traditional epistemologies within the framework, it holds their congruence as a function of the holistic truth represented by the unified universe. And this is, we just talked about all this, but the point here is that the philosophical predicate priority is unification. It is not any other consideration. It's important to make sure that when we're saying something is true, that we're saying it's true in full alignment and congruence with, and congruence is another one of those C words that's in the realm of C's that are articulated on the website. And I want to take that opportunity to encourage people to go to the website, SolREI.co, and register, and then you can start seeing the web pages that articulate all this detail. So that's the epistemology and the philosophy of truth behind it, and it gives you a different set of insights on how you talk about things and how you articulate truth. And if you can say something is true from an elegant reasonism point of view, it means it's consistent and has high affinity with the unified universe, and that's different than an empirical truth. Empirical truth means that's what you perceive through our human physiological senses and what we can document, and even in a repeatable fashion. And since I'm here at an airport, the distinction between an empirical truth and an elegant reasonism truth might be the distinction between visual flight rules as a pilot and instrument flight rules as a pilot, and what you can do with those two things. There are situations as a pilot where you may maintain a 1G, 1 gravity environment inside the aircraft, but the aircraft is in fact doing a barrel roll, for example. There's a great video on YouTube of Bob Hoover doing exactly that. In fact, he's pouring a glass of water from a pitcher while he's at the same time corkscrewing the aircraft through a barrel roll in flight, and he never misses a drop. Every drop of water goes into the glass because he made a 1G turn the whole way around. We have other examples that are on the website that you can go see, but the point is that the analytical rigor and discipline that elegant reasonism brings to the table penetrates beyond human physiological senses, and it integrates the belief systems associated with those two things through that Bayesian analytical layer, and back out to treatise when you back up and look at the holistic framework that this represents. So the other thing that elegant reasonism imposes are QMS standards. QMS is quality management standards. It's usually, when we say that, we usually are referring to ISO 9001 QMS, and you can see that at iso.org on the web and see what the documentation requirements are for that. There's a number of quality metric systems like Six Sigma, the thinking hats, root cause analysis, etc. And they all have their own metrics and their own documentation processes, and you can go and bring those into elegant reasonism as well in order to meet the goals and objectives that you may have for a given investigation. On the other hand, if you just want to do something really simple and knock something out on a whiteboard because you're doing something really quick, you can do that too. You don't have to do all this other stuff, but if you want to do a formal treatment of it, then the framework allows that and supports that and integrates that into what it is you're doing. But the fundamental reason that we're we have to include all these different things is that when you're mode shifting from M1 to M5, any given paradigm, what changes is context. And context is something that nobody ever anticipated changing. We never thought we'd be changing how we define space, for example, or how we define energy, or how we define mass, and whether or not mass is variant or invariant. That decision, mode shifting that decision, is something that requires a great deal of discipline and rigor in order to accomplish. And we do that with ISO 9001 QMS quality management system standards. And we measure the sigma defects with that through the Six Sigma process. And the intent is to reorient context and to make sure that we have a holistic view of that, and we can do that. And then as we document it through the Bayesian statistics, that helps us build the education roadmaps that flow out of that. And then we can have a discussion with teachers on how we move a set of students from that part of the woods to this part of the woods. And are we on the precipice of unification? Do we see things in a different way because we move them from here to there? Okay, the bodies of work and the people, the three primary people that, if you go to the website, you'll see an acknowledgements page there, and we have a lot of people who helped us hone and build what it is we have here. And there's too many people to list in a video of this nature, but the three people that float immediately to the top out of that is Albert Einstein, Suzanne K Langer, and Dr. Lev Biokin. Einstein obviously did the special relativity and general relativity, and two important quotes that he is associated with is that we cannot solve problems using the same thinking that we used when we created them. And he was more right than he could have ever known. I mean, who would have ever been able to think that he would have committed a Langer epistemology error and that nobody ever caught it until we did it as part of the body of our work. And because what he did was logically correct. And we have great successes based on that logical correctness. And people want to say, well, the science is correct, and well, the math is correct, and it can't possibly be wrong. And it's not wrong. It's just logically correct. And when you understand the implications of logical correctness and what that means, it means that there might be something else that's also logically correct. And there is. It's called the emergence model. And so we just have to change our thinking, and we have to have a framework in order to do that facilitates that change in thinking, and it quantifies and codifies it, and does so in a consistent manner that's definable and repeatable, consistent with the scientific method that we can then use to articulate what it is we did to other people around the world. And when we do that, that's when all of this becomes very, very powerful. It's just incredible. Suzanne K Langer was a philosopher. She was the first American woman to be recognized both professionally and personally in that regard. And her philosophy and its taxonomy, her contribution was the situational awareness that if you mistake abstractions for reality, that is a fatal flaw in epistemology. And when we saw her work, we named these errors after her in her honor, to remember the body of work that she did. If you go to the user library that's up on SolREI.co and look up, we have some of her work there that was out of the public domain, and you can see that there, and you can read her words in her own language, how she articulates those, and we tell you exactly where to go to see what you need to see in order to come to the same conclusions that we came to. Her body of work primarily centered on a piece of work she published in 1948. So it's not new. It's just never been all pulled together into this framework before in a way that was situationally aware of the implications. Dr. Lev Oken is the third person that we, at least for me, was a very, very important person. And he unfortunately passed away during the conduct of our systems review, and we wish we had been able to more efficiently engage him, but because he was in Russia, and there were all the things that were going on a geopolitical front, really did not allow us to engage the way we would have liked to. But we recognize him here. He wrote an article a long time ago called "The Concept of Mass," and it takes that concept back through history, and he showed that Albert Einstein did not believe that mass was variant. He believed that mass was invariant. Why and all of that. And so that was the foundation that actually forced us to distinguish M1 from M2, and we wound up with the set of encapsulated interpretive models that we wound up with, and all of that is online in the user library as well, and you can go there and look that. All the registered users are able to go and look at that. We don't charge anything for any of that. You can just go read to your heart's content. So Einstein said, we cannot solve our problems with the same thinking we used when we created them. Who would have thunk that, the thing about, the one knee-jerk reaction that we get a lot is people saying, well, look at all the evidence we have. Look at the empirical evidence. How can all of that be wrong? And our answer to that is that it's not wrong. It's just logically correct. And so when you realize that and you understand the implications of that, then you realize that when you do a logically correct experiment that is immersed in a logically correct model, and it's conducted in a logically correct manner, that it's more than likely going to produce logically correct results. And that has absolutely nothing necessarily to do with the physical system underlying it, except that it has more to do with the logical correctness about which you did all those other activities. Because something can be logically correct and still remain physically different. It's just that the physical system underneath it has to be able to support the logical view you articulated and followed. And so what we've done for the last 120 years has been logically correct. And we back up and say, this is why, when we look at elegant reasonism, this is why we have unification as a philosophical predicate priority consideration. You have to ask, it may be logically correct, but does it unify physics? Does it accomplish unification? And because it's a larger tapestry than any single discipline of science, is one of the reasons we've had to stop using the phrase of physics with that word unification, because it's bigger than that. We have to do a whole lot more than that. We'll talk about that later in another video. And this next chart is the example of handwritten letter from Albert Einstein to Lincoln Barnett, 19 June 1948, where he said that it's not good to introduce the concept of mass of a moving body for which there's no clear definition can be given. He said it's better to introduce no other mass concept than the rest mass m. Instead of introducing m, it is better to mention the expression for momentum and energy of a body in motion. And so those are the distinguishing characteristics between M1 and M2. And I'll just leave that there. But it's historically accurate, and it reflects how people actually believed. And so it is, and the point here is that it is erroneous. It is erroneous to say that Albert Einstein believed in the core constructs of M1. He did not. Modern science does, but Albert Einstein did not. And then we come to Suzanne Langer. What a wonderful lady she was. I wish I had been around then to meet her, and I would have loved to have been able to talk to her. But she said, you know, the world of physics is essentially the real world construed by mathematical abstractions, and the world of sense is the real world construed by the abstractions which the sense organs immediately furnish. To suppose that the material mode is a primitive and groping attempt at physical conception is a fatal error in epistemology. It is incredible at the insights she had, and I believe that's on page 72 or 74 of her book, Philosophy in a New Key. I'm not sure if each additional printing of the book had it on the same page or not, but that's in that general part of the book. She also pointed out that if we would have a new knowledge, we must get a whole new world of new questions. And elegant reasonism brings those new questions in spades. There's not enough time in any given video to begin to articulate all of those. And again, we have thousands of pages of insights documented that we're working to get into video and get onto the website. And as we do that, we hope everybody will bear with us, but we understand the impatience, and everybody wants it all there now and wants to be able to snap your fingers and have everything appear so in a way that everybody understands it. The challenge is we're having to mode shift fundamental context, and hopefully I've been able to give you a little bit of insights so far to help you understand why that's a challenge. That we have to mode shift those things, because the framework and the context under M1 is one pattern, and when you mode shift it to M5, it's a different pattern. But the paradigm that is being mode shifted is the same. And because we can have multiple simultaneously logically correct answers for the same paradigm, makes this an incredibly difficult and challenging subject to broach with people who are not ready to hear the answer. And that's why we are moving to the web, and that's why we are moving to video, and that's why we are taking the time we are taking to bring this out to civilization. It gets a great deal more involved when you start talking about enterprises and business processes and the global economy, not to mention geopolitical aspects to all of this. And so it's very important. We're bringing it out as fast as we can, and we hope that you have some patience with us, because we are a very small organization, and we're doing what we can do with what we have. If somebody wants to help us, then call us and we'll talk. So behind the general processes is recognition awareness, requirement specifications, systems engineering, certainly in order to be able to specify out requirements and have discussions about systems and systems of systems and logical views of physical systems, quality management systems at every step and stage, and then we also have to back up and look from a consulting point of view, investigative objectives, goals, and the approach. Because if the goals and the objectives are not articulated correctly, then the results may not be correct either. And it may be that the investigative team and the team leaders need to go back to the people who handed those goals and objectives down. May have to have some discussion there to make sure that everybody stays on the same page in a going forward manner. Langer epistemology errors need to be understood. They need to be recognized, illuminated, and analyzed. Go through the same 3 steps there and use translation matrices and use that unification tool if you find it of value. If you don't, then you can use one of your own. But the process and the framework requires that those definitions be quantified and codified. And so whether you use our tool or your own tool, it doesn't matter as long as the same result is made manifest. The practices, it's the same 3 processes no matter what your investigation is. It really kind of doesn't matter. But you have to quantify and codify, encapsulate, enumerate, and iterate when you start talking about models. If you're looking at the emergence model, that's fine. And if you're looking at it and relative to, say, you're used to using M1 and you do that and you go through a translation matrices and you're filling out the M5 columns and you're working with your paradigms of interest, whatever those happen to be, you may find something that you're not aware, you don't understand how it can be made manifest in M5, and you may come up with a requirement to build another model. But going through a systems review to build a model is different than going through a systems review and using models that already exist. And so it took us 16 years to come up with the emergence model, and it was very costly on a number of fronts, not just financially, but it took a human toll too. And so those are not considerations that should be lightly contemplated. But the intent is to integrate tools and the analysis and the analytical thinking in a situationally aware manner. That what I mean by that is that, when you're looking at something, you have to be mentally aware, does this represent an M1 concept or does it represent an M5 concept? And can I mode shift between the two, and can I do that in a real-time manner? And if you can do that, that's great. It's hard for people to do that. And it is not for the faint of heart. So, but you want to do that, and you want to do that in a way that everything is documented, consistent with ISO 9001 QMS and Six Sigma and all the other external industry standards for quality. The Malcolm Baldrige process is yet again another framework that you could use as well. You can use all these things at the same time if you want to. If you have those kind of resources available. Philosophy. There are a lot of people who will tell you that science and philosophy separated probably sometime back in the 1700s, maybe the 1600s, when the scientists began to use the laboratory. And that's when people started to think of science as something different than philosophy, because philosophy is it's rigorous, but it's a mental. You sit in an armchair and come through philosophical interpretations of things. But at the end of the day, the way humanity and civilization evolved, it is important to remember that science is only the new term for what used to be called the philosophy of nature. This is why it's important to understand that when we say unification must be a philosophical predicate priority consideration as you enter science, you must require that you're thinking about how you're looking at the realm in which we exist is unified. And that's what we did when the system was review that we did, and we took it through. Because we didn't do that when we started out. We were not there. We had to, that little insight came as a function of us conducting the system review, and it was hard won. I will share with you that we had unified physics and we had accomplished unification, but we did not realize that for over 2 years, 2.5 years. And it was right in front of us. It was right under our nose. And we didn't know we'd done it. And once we did realize it, and we went back and we began writing all this stuff up and then said, what are we going to do with this? And because of the challenges that are in place that make it so difficult to communicate this to other people, is one of the reasons that we had to file a patent, because nobody wanted to believe we'd done it. And so now that we have done it, and we do have the patent, and we are in place, and we are protected worldwide, nobody can deny that we did it. It's there, it will be rolled out. These videos are here to help people understand what it is, what the framework is, how the epistemology works, and the philosophies behind it. So philosophy is important, but then the philosophy of science is also important. So is the methodology and the frameworks and the foundations of science and the laboratories and how we do that. But it's also important to recognize the limitations of human physiology. It's also important to understand ontology, which is the philosophical state of being, and the study of that, and axiology, which is the philosophical study of value derivation. How do we find value? And so, for example, if we find value in achieving alignment with the context of M1, that's one set of values. If we adopt a larger view and we say we want to have develop value as a function of an elegant reasonism alignment with the unified universe, that's an entirely different matter. That means we have gone through the analytical rigor of that framework in the translation matrices. It means that we've looked at the Bayesian analytics of the different belief systems before, during, and after our investigation. It means that we've done all these things in a way that we can document it and communicate it to other people in a treatise that is ultimately aligned with the unified universe, and in a way that we can develop education roadmaps from that exercise and carry that out into all subsequent textbooks and education approaches, and teach our progeny and students at all levels, K through 12 and higher ed and post-grad and all of that. And so the philosophical approach to these things is important from a taxonomy point of view, to make sure that we can prioritize the predicates in a cogent manner, and that all of those considerations also meets the realm of C's. And so I encourage everybody to register on SolREI.co and begin to engage this material and look at not just the material that we've written so far, that we've had time to get integrated on the website, because there's tons of stuff up there that are not finished or not complete, and I know we're going to get lots of bad letters about all that, but it is what it is, and we're working as fast as we can, and we have this body of work that we're trying to integrate up there. We just don't have enough, there's not enough hours in the day for us to do that. We need help. getting this done. We would love to be able to do it faster, and we're looking and exploring for ways to accomplish that. We're just not there yet. So, truth from the unified universe. The unified universe intrinsically exemplifies ontology, axiology, and epistemology. Because the universe is, we simply need to look up at the sky at night, either with an instrument or with the naked eye, to know that that's the truth of those things. The universe is. The universe is unified, whether or not our contemplations of it are. And so the elegant reasonism framework supporting its epistemology manifests axiology through human action in order to deliver a strong sense of ontology by seeking truth as a function of the unified universe. And I will say here that when I say the words human action, I mean human action in the context of the treatise that Ludwig von Mises wrote on economics. And so it's ironic to me that the Mises Institute for Economics happens to be located at the same place I went to school. It's Auburn University in Alabama. And I think that's just a wonderful piece of irony that it boggles my brain that is all true. Anywho, it is what it is. The elegant reasonism epistemology, this next chart, which is chart 28. The goal of it is to make sure that you're situationally aware in any given moment, instant to instant, of the context of the contemplations being undertaken, and which interpretation is manifesting that set of perceptions. Full compliance with elegant reasonism implies that you are aware of the framework, what the rules are, the tools and technology, and the standards and the principles, and that you are following those with discipline and rigor, and you're quantifying and codifying at every step and stage all the way through the process, at least in a simplistic manner, and that you're not forgetting anything. And that way that you can have an effective ability to mode shift those paradigms of interest, and that you, when something is simultaneously true and you understand that there's multiple ways to interpret the same paradigm, that you're aware of those things and the implications of those things. And that flows all the way out to the ISO 9001 QMS standards, Six Sigma, the plurality of encapsulated interpretive models. And that is one of the reasons that we have the requirement of plurality. So, for example, it's not consistent. It's incongruent with the rules of elegant reasonism to have an investigation and only use one model. No, you need to have more than one model, a minimum of 2 models, if not 3 or 4, to fully, because remember, you want to illuminate and you want to illustrate the different manifestations of any given paradigm, and you want to do that consistent with the Bayesian analytic requirements, for example, of the belief systems before, during, and after your investigation, so that you can say, well, I understand that we used to believe this because it's consistent with M1 saying this, this, and this, but when we mode shift those over here, we then shift through Bayesian Analytics and we see that this pattern moves over here, and that now this is true, and this is why this is consistent with the unified universe, and that's not. That does not close, this does. The philosophy of science. Science is a specialized branch of philosophy employing methods and tools used to describe nature in an independently repeatable and holistically in context of the unified universe. It's a repeatable approach. Some people would say that that's what empiricism is all about, but empiricism is intrinsically tied to human physiology, and we need to not forget that. We build our physiology into the very instruments we use for science. So if we look at this airplane back here, for example, we see that the console, the layout, the six-pack of the instruments, it's conducive both to VFR flight and to IFR flight. And so the instrument flight rules, I'm sorry for those that are not pilots. Visual flight rules means that we're doing seat of the pants kind of flying. We can see where we're going. We're not limited by weather or nighttime or other things. But if we have to use our instruments because we cannot see past the glass in the cockpit, then we must depend on our instruments. And there's a number of things that we can do. And again, I would encourage you to watch that Bob Hoover YouTube video of him doing a barrel roll and pouring a glass of water at the same time, because he doesn't spill any of the water and he does a barrel. He turns the airplane upside down and the water still goes in the glass. And the point there is that our physiological makeup as humans, even though the empirical evidence says it is this. So for example, one of the predictions from relativity is seeing two images of the same star being gravitationally lensed around a distant gravitational object, and we've been able to prove that, and Einstein is often touted as a prediction of relativity, and it's correct, and it is logically correct. It does make sense. However, we can mode shift the M1 and M2 manifestations of gravitational lensing over to M5 and see that gravitons would produce the same result. So those are things that we all have to take into consideration. Tools. There's a lot of documentation that you can use that are not mentioned in the presentation here. The ones that we do mention, the ISO family documentation is on iso.org. Root cause documentation, you can use fishbone analysis, value chain patterns, encapsulation model patterns. ISO 9001 unification tool, it's a piece of software that's on our system that you can get to define the quantification codification that results in the model interaction and enumeration and iteration. Translation matrices and the analytical layout that we have there. But you can use other tools too if you think they will be of use. This is just sort of an example list, if you will. You don't really want to use less than this if you want to do a formal treatment of something, but if you want to knock something out on a whiteboard for a discussion with a group of colleagues, then you're more than welcome to do that. We strongly encourage everybody to keep everything as simple as possible. The acronym KISS comes to mind. You don't want to make things more complicated than they need to be in order to get the point across. But again, philosophically, you have to make sure that you're not losing sight of that predicate priority consideration, unification, because it's important. When we start looking at the objective of mode shifting in a dynamic manner, we have to do that because encapsulated interpretive models establish fundamental foundational context. That word context, it's another one of those C's. The integrity associated with translation matrices cannot be understated in terms of value and approach, and the integrity associated with that rigor and discipline. The mechanics of the mathematics might not change, but how all the associated variables and their definition likely does change, and they must be 100% so shifted. They have to be mode shifted also. And so, for example, the speed of light might not change from M1 to M5, but the reasons it's the same, the reasons for that constancy do change. For example, in an M1 discussion of chemistry, we might say that photons of some frequency from some element going from quantum state 5 to quantum state 3, or the shells, the electron shells in the atom, and that's why light is doing what it's doing in the frequencies, and et cetera, et cetera. Not until we really understand and we mode shift that, and we also integrate synchrotron radiation, do we understand how centripetal force comes into play relative to the architectures of mass that produce the photon. Do we really start to understand what's going on back over in that M1 scenario within the atom, and that there are architectures of mass relationships that maybe we weren't thinking about before. We may need to have a discussion about prions, for example, configurations of MBPs that are not yet formed into particles that we might recognize, or particles that only stay configured because of their internal resonance for very short periods of time. We also can integrate supraluminal kinds of discussions as well, because, and that's a subject for another video. I'm not going to talk about that here, but there's all sorts of issues that become relevant when we mode shift from M1 to M5 and back again, and we need to be able to do that in a dynamic manner. And being able to do that in a conversation means that you are situationally aware of those implications and the requirements to have those conversations and why they're important. The one thing I would like to, on this next chart about mode shifting existing knowledge, the takeaway here is really that we're not having to start over. We can take what it is we already know and mode shift it with this process. And the more you use it, the easier it gets to do. The better you understand it, the easier the contemplation becomes, because you've done it and you understand where things will be. And once you're on the precipice and you can see all these different issues, it almost becomes intuitive. And it will help you to not only to understand what it is you're experiencing in terms of your investigation and in context of that investigation, it also helps you to understand in terms of being able to communicate with other people, especially people who understand what this process is. And so the more you do that, the more you'll understand. And you may look for things that you weren't looking for before, or things that you thought you understood that you really didn't understand. And I can think of lots of experiments that are going on right now in some fairly major institutions, and I can tell you that those experiments and all the money and the resources that they're spending to conduct those experiments, they're off base. because they're looking for something that's only logically correct, and they do not know how to mode shift things, and they're looking for the wrong thing in the wrong place, and they're misinterpreting the results that they are getting as confirmation to what they've done, and it's nothing of the sort. And so I can only encourage people to really thoroughly engage elegant reasonism, register on the system, beat it up, explore it, start looking at it, throw darts at it. Don't take our word for it. Really engage it, understand, learn how to wield it yourself. The material that we have there is only fodder for you to do that. The system and the process and the framework are only going to get better when more people are using it. And if somebody can come up with a better model that closes to unification, that's fabulous news. We hope that's the case. But in the case that it's not, and in the interim, we offer the emergence model. And we offer it there for anybody to go use and make better. And it's what we are bringing to civilization. It's our contribution to civilization. And I guess probably too, it's part of our legacy too. So we hope you're able to use it to great effect. And we certainly hope that it helps your insights. This next chart is a paradigm shift chart, and it's chart slide 33 in the deck, and it says all of these plates are flipped upside down except one, and when you see that one, they'll all be right side up. It's a static chart. The paradigm shift occurs inside your mind when you look at this, and I'll give you a little clue. There's not one trigger plate. The trigger occurs when your brain is able to interpret the plates or the bowls in a different manner. The challenge will be for you to exercise being able to shift your interpretation of the plates back and forth between the two views, and do that at will. Do that in a situationally aware manner, and understand what it was that's allowing you to do that, and do that in a situationally manner. And when you can do that, and you can do that at will, then you'll have a better chance of being situationally aware in an elegant reasonism-based investigation or a solution. Slide 34 is shot of Niels Bohr. He says isolated material particles are abstractions, their properties being definable and observable only through their interaction with other systems. And again, we point out that in elegant reasonism, everything is a system or system of systems. And we have to understand the implications of Langer epistemology layers or errors across the layers between humans and reality. And there may be 10 layers. There may I think Deepak Chopra in his current book says that there's at least 5 layers. That chart that I showed earlier, I think there were 8 layers in that chart. It doesn't matter. The point is, we have to be aware of how far down that chain of layering the details manifesting those abstractions really are. For the people who want to say that, well, the math is right, you know, if you said x equals yz squared and wrote that up on a board and said, well, if the math works, then why don't people recognize that as E equals mc squared? And the point is that the definition of the variables matters. And the reason it matters has nothing to do with math and everything to do with physics. And the constructs of the abstractions that manifest meaning behind the E and behind the M and behind the C and the squared. And we have to be able to deconstruct how c squared dismantles into the space-time framework and that logically correct construct. And then we have to be able to have discussions about if E equals mc squared, then why doesn't it all the time? Why does mass not devolve into energy instantly? Why isn't everything just dissolving into energy? Well, nuclear engineers called E equals mc squared the nuclear binding formula because it's bound up unless you exceed that c squared part, and it stays there. So there's all kinds of discussions we'll do in later videos. You know, the one concept I would ask you to think about is the space-time mass interface, and what that means to mode shift content and context in your own life and in things that you are familiar with on a daily basis and can do that in this new framework. Slide 36 is another chart. You may have seen this, or you may not have seen it, I don't know, but the idea is to connect these 9 dots with exactly 4 straight lines. And if you know the solution, that's great. That's actually not the problem. The challenge is to, like the plates, is to recognize what it took for you to gain the precipice where you saw the solution, and to recognize what within yourself was keeping you, what was the inhibitor preventing you from seeing the solution. Those are the things that are the reasons why this puzzle is in this deck of charts. So noodle on that, and if you don't know what the solution is or have never seen this before, you know, draw this on a piece of paper and connect the dots with 4 straight lines, and then study on it until you do have the answer. And then when you gain the answer, think about what was constraining your ability to see the answer, and then think about all the other things we've already talked about, and you'll start to understand the applicability of this little puzzle to all of that. This next one, chart 37, is a thing about details and clues, because they matter. I could point out that the geometric basis point is routinely dismissed in M1, but it matters because we need to be able to have relationships between real objects in the same frame, and we can do that in M5, but we can't do it in M1, and we can't because no real object can transit the space-time mass interface. That interface does not exist in M5, so we don't have that problem. So this picture of this what looks like a glass of water is actually not a glass of water. It is an inverted glass, and the picture has been rotated, but what looks like water in the bottom of the glass is actually an air bubble, and the air is maintaining the glass against a white surface that you can't really see in this picture, but it's holding it upside down. It's immersed in a clear liquid, presumably water, but it doesn't have to be water. And the point is that just because you see something that looks like it fits what your interpretation is, don't presume that there's not another interpretation for the same image. There can be simultaneous truths for the same set of circumstances and the same real objects. And we have to mode shift those between M1 and M5. And that's what we're trying to get people to think about when we show them this chart. And good old Winston Churchill. Men occasionally stumble over the truth, but most of them pick themselves up and hurry off as if nothing ever happened. Nothing could be further. I mean, that's just happens every day, happens every hour of every day. It's just a reminder to make sure that we're doing our due diligence, and we're doing it across a framework that is in fact aligned with the unified universe. The last chart is the epic so what chart. I'll let you read these bullets on your own. I don't really need to read them for you, but we've been able to describe the universe bang to bang. We've gone back through the WMAP data. There's actually a very old interpretation of the Big Bang that's coming back into fashion, or to style, if you will. It's consistent with M5, and using that description, that 120-year-old description, and we've been able to look at that and realize that with severance as the failure mode of architectural mass, we realize that mass is frangible under M5. And that frangibility of mass, that manifests itself into the universe and the Big Bang. It's consistent with the WMAP data. When we realize that knot theory has an intrinsic convergence pattern associated with it, we can even realize the relationships that Euler had with the beta and gamma functions, and how and why that relates back to string theory. But more than that, we can even understand how polar properties are made manifest. And when we do that, we realize that electricity is not the only thing that's polarized. We can polarize gravity along a different dimension of high mass, low mass, and it has a function of architecture. And when we do that, we realize that at some distance, gravitons reverse polarity. And that's why all the galaxies are flying apart like they are. And when we put that into the cosmology models, and we understand them in the context of more considerations with black holes and whatnot, which we'll put into other videos and we'll do later as soon as I can get to it. We now have a consistent ability and description to describe the universe literally bang to bang, and consistent with that single cogent description, that single cogent paragraph that's in the charts earlier that we've already talked about, and do that so that that affinity, that truth, lines up with all the other truths that are delivered by elegant reasonism. I cannot begin to understate how epic being able to do this is. This is important. It's never in history have we had a single cogent paragraph that's scale invariant and able to show us all that is. You can go through these other bullets, and if you have questions, then right now we have the comments turned off on the YouTube channel, but at some point we will turn those on when we have more hands and can actually answer the questions. I apologize for them being turned off at the moment, but we're resource constrained, and we just simply don't have the ability to answer questions that we know everybody has. We apologize for that, and we'll get to them as soon as we can. We are trying to put as much material on the website so people can begin to go through and assimilate what this means to them. With that, I want to thank you for your time and attention, and we'll be around and we'll be producing more videos, and hopefully we'll be able to do this maybe a little better next time than we did this time. Thanks a lot. Take care and talk to you soon. Bye-bye.